Alright, in this video we show that the sum of two independent normally distributed or Gaussian random variables is again a normally distributed random variable. More specifically, if x is a random variable that follows the normal distribution with the mean of mu x and the variance of sigma x squared, and y is another random variable that follows the normal distribution with the mean of mu y and the variance of sigma y squared, then x plus y is a random variable that follows the normal distribution with the mean of mu x plus mu y and the variance of sigma x squared plus sigma y squared. Okay, let's start. First, let us define z as the sum of x and y, and we try to find the density function of this random variable, and which is found as this. Integrate from negative infinity to infinity and dx. So we move x from negative infinity to positive infinity. And the density function of x is this, since it's normally distributed. And exponential of x minus mu x squared over 2 sigma x squared. And times the density function of y. Since they are independent, it's just the joint distribution is just the product of two density functions. And exponential of y minus mu y squared and 2 sigma y squared. However, since z is x plus y and we fix the value of z, so if we move x, the value of x, then the value of y should be z minus x. So we should replace this y by z minus x. Okay, now let's tidy this up a little bit. Let's put these constants out first. Integrate. Exponential. So let's combine these together. So negative 2 sigma x squared, sigma y squared, and sigma y squared x minus mu x squared, and plus sigma x squared z minus x minus mu y squared. Next, let's complete the square of this part. To simplify the notation, let's put z prime as z minus mu y. Okay, then this numerator becomes sigma y squared x minus x squared plus sigma x squared z prime minus x squared. So let's expand this. So now we have x squared here and x squared here. So let's put them together to have sigma x squared plus sigma y squared times x squared. And we have x here and x here. And let's put them together to have 2 sigma y squared mu x and sigma x squared z prime of x, and then the rest, sigma y squared mu x squared sigma x squared z prime squared. Now we have this quadratic form of x and we want to complete the square, and that becomes x minus And let's put all the rest as e. So for the moment, let's just put this e as e, and let's move this back into this integral. So we have this integral. Integrate over x exponential of, don't forget these factors. We have negative, let's see, sigma x squared, sigma y squared, sigma x squared, sigma y squared, x minus something squared, right? And if we integrate this, this part doesn't mean anything after all. So the result is, oh wait a minute, 2 should be here. And the result is square root of 2 pi and the inverse of this. So that's sigma x squared, sigma y squared, sigma x squared plus sigma y squared. So that's it. So let's substitute this into this. Then we have the original integral. So rho z of z is this 2 pi sigma x squared, 2 pi sigma y squared times this 2 pi sigma x squared, sigma y squared, sigma x squared plus sigma y squared times exponential of e over 2 sigma x, what is it? Squared sigma y squared. So this 2 pi cancels this 2 pi and sigma x squared, sigma x squared, sigma y squared, sigma y squared. So they all cancel and we have 1 over square root of 2 pi sigma x squared plus sigma y squared times exponential of negative e over 2 sigma x squared times sigma y squared. So what is this e? Okay, if we go back here, so let's see. So e should be these things plus these things minus this thing squared times this factor. Okay, so that's negative sigma y squared mu x plus sigma x squared z prime squared over sigma x squared plus sigma y squared plus sigma y squared mu x squared sigma x squared z prime squared. And let's expand this part and make the common denominator. Sigma x squared, sigma y squared minus, let's see, this thing squared. So sigma y mu x and sigma y squared mu x sigma x squared z prime. This should be negative here. And negative sigma x to the power 4 z prime squared and plus let's see, sigma x squared sigma y squared times this. And let's expand this. So if we expand this times this will cancel this one, and this times this will cancel this one. So what's left is this times this. So sigma x squared, sigma y squared, z prime squared, and this times this. That's sigma x squared, sigma y squared, mu x squared. And this term, 2 sigma y squared mu x sigma x squared z prime over this. And let's see. So all these terms contain sigma x squared, sigma y squared. So we can factorize. And z prime squared and mu x squared minus 2 z prime mu x. And that is z prime minus mu x squared. And let's put z prime back to z minus x. What was it? Z minus mu y. So that is z minus mu x minus mu y squared. Okay, let's put this back into here. Then the density function of z is square root of 2 pi sigma x squared plus sigma y squared exponential of this thing over, look, yeah, we divide by sigma x squared times sigma y squared. So that will cancel this term. So we have, after all, negative z minus mu x plus mu y squared sigma x squared plus sigma y squared. So this is the normal distribution with the mean of mu x plus mu y and the variance of sigma x squared plus sigma y squared. So therefore, z follows the normal distribution with this mean and with this variance. And we are done. Now it is quite easy to generalize this result to any number of variables. So let's say we have x1, x2, and so on up to xn, all of them following Gaussian distribution or normal distribution with some mean, let's say normal distribution with mean of mu I and the variance of sigma I squared. So I is from 1 to up to n. Okay. Then the sum of these Gaussian random variables is also a Gaussian. So, and the mean is of course mu1 plus mu2 plus and so on plus mu n. And the variance is sigma 1 squared, sigma 2 squared plus and so on and sigma n squared. Okay, that's all for this video. See you next time. Bye. Thanks for watching. If you like this video, please hit the like button and subscribe to this channel. See you next time. Bye.